So learning about radians opens up every single question you've done in the past with degrees. Now just the same questions get asked with radians. So there's just a slight difference. So we had this question, P negative 4,3 is the terminal point of an angle theta in standard position. We did this a couple of days ago with degrees. The only thing difference now is they're telling us radians. This same question in degrees, instead of negative 2 pi, it would have been negative 360 degrees less than theta less than 360 degrees. And if you imagine what that domain means, can you imagine that on standard position, starting with 0 here, that would be once in the positive direction, because that would be 0 to 360, and once in the negative direction, because that would be negative 360 to 0, or 0 backwards to negative 360. Now that we're dealing with radians, it's exactly the same thing, but now all of our answers need to be in radians. And it makes it a little bit harder just because you're not used to working with them. And you're not used to seeing if your answer is right or not. Because here, if you get an answer of 500 degrees, you would know that you're wrong because it's way outside of what range you're looking for. But when you get an answer of 5 radians, you're just not used to it as much. You might not recognize that, well, 5 radians would still be okay, but 10 radians wouldn't be. So this is what it looks like. Same idea as before. We go to negative 4, comma 3. Draw that point on our terminal side of our arm. And we can think this will be our angle theta in the positive direction. This will be the angle theta in the negative direction. But once again, we draw a triangle because then we can label a reference angle. On our triangle, because the point is negative 4, 3, this length is 4, this length is 3. And if I wanted to use a right angle triangle to find out what that angle is, there's my reference angle. I know the opposite side is 3, the adjacent side is 4, so I would use tan. Our calculators are still in radians, so when you do tan inverse of 3 over 4, and that's to the nearest hundredth. When we write our final answer, we can round it to the nearest tenth. There's our reference angle. Yes? You know what? If I'm just thinking of this as a triangle, though, because if I want to do a reference angle is always positive, and it's always an angle inside that triangle. The length of this side of the triangle is 4, and the length of this side is 3. If you label it as negative 4, that's fine, but you will get your reference angle wrong, because reference angles are always positive, and so they always deal with actual triangles with positive lengths. Yes, it should be squiggly. See? Perfect. Nice. So there's our reference angle. Now we have to figure out what the blue angle is. The blue angle theta. How would we do it in degrees? If we knew this reference angle in degrees, and I'll just figure out what it is in degrees just so we have a reference point. Haha, no pun intended. 37 degrees. Okay? If you needed to find the blue one in degrees, do you agree that you would take 180 and subtract that 37? So now we do the same idea, but we use radians. Instead of 180, we do pi radians. Instead of 37, minus 0.64. That's the same thing as saying 180 minus 37. Now we're just doing pi minus that, and we get 2.49, which rounded to the nearest tenth would be 2.5. The negative one. Can you see if you were dealing in degrees, you would go 180 plus 37 to figure out what this red angle is, and then just make it negative? So now we do pi plus 0.64. I get 3.785, which means our red angle, theta, could also be, squiggle, 3.8, negative. And those would be the two answers from negative 2 pi to 2 pi. So the ideas are identical. Again, what did I do? I just took pi plus my reference angle and made it negative to figure that out. We did questions like part B as well with reciprocals and degrees, so now we can do them in radians. First of all, cotangent isn't on our isn't on our calculator. So we change it to its reciprocal. Okay. Cotangent to tangent. It's not the angle, it's the other side. So here I could do the reciprocal. I'm going to get 1 over negative 2. Again, we would like to draw a triangle. We know that the opposite over adjacent has to be 1 over negative 2. We think of our cast rule and imagine where is tan negative. That can happen in quadrant 2 or quadrant 4. So if I draw a triangle in quadrant 2 and label opposite over adjacent as 1 over 2. And again, I'm going to use positive values here because I'm thinking of the actual right angle triangle with the reference angle. It could also be in quadrant 4, 1 over 2. There's my reference angle. That reference angle will be the same in both of those triangles. If I wanted to find the reference angle, I'm thinking about an actual triangle. Whenever you're finding the reference angle, the negative is not involved. And then when you find tan inverse of 1/2, 0.464. Now we need to find all of the answers, check the domain that the question was asking from at the beginning. They want negative 2 pi to 2 pi. So if we think about starting in standard position, the positive angles, 0 to 2 pi, would go once around. The negative angles, 0 to negative 2 pi, would go once around. Can you see for the positive one that we would have two answers? If we look at the triangles we've drawn, we're going to get one answer here and one answer here. We'll also get two answers for our negative ones. We'll get one answer here and one answer here. So let's figure out our positive ones first. If it was degrees for the first positive angle, you do 180 minus whatever the reference angle is. Now we're going to do pi minus the reference angle. Again, I'm going to show you this on your calculator because this is where we use our reference angle 4 times in this question. It's going to be really helpful if we store it as x. So again, I found my reference angle by doing tan inverse of 1 divided by 2. I get that 0.463647. I'm going to store that as x. Right above the on button is the store button. That's really helpful now because I can just go pi minus x instead of anything else and find out my first answer is 2.67. They want me to round to the nearest tenth, so that would just be 2.7. Comma, because I have a second answer here in blue. For that one, if I was dealing in degrees, do you see that I would go all the way to 360 and subtract my reference angle? So now in radians, I would go all the way to 2 pi and subtract my reference angle, which I can just subtract x because I've stored it, 5.8. Those are my 2 positive ones. For my 2 negative angles, the first one's going to be easy because it's going to be exactly the same as our reference angle, but just a negative answer. So instead of negative, so 0.464, but rounded to the nearest tenth would be negative 0.5. And for this one in quadrant 2, if you were dealing in degrees, you'd go 180 plus your reference angle. So now that we're dealing in radians, I'd go to my calculator and say pi plus my reference angle. That's 3.6, but since we're going in the negative direction, that would be negative 3.6. And then we have found all the angles of theta between negative 2 pi and 2 pi that satisfy that equation. If you wanted to check if your answer was right, so if I wanted to check if times by a negative, so that negative 3.605. If I wanted to check that that's right, I'm going to just see what is 1 divided by tan of that answer. Because if it's right, it should satisfy the original equation which said cotangent is equal to 2, negative 2. And that was what our original question was asking. When is cotangent equal to negative 2? So I plugged in my angle, and sure enough, it came out to negative 2 as a way to check. Okay, yeah, I'll scroll down to the bottom here. 13 and 14 are the ones that you can do.